not hearing anything. Turn the volume up. Oh. Recording? Hello? Hello, hello? Yeah, there is some recording. Let's share now the all right. Maybe I need to switch off that light underneath it or put more paper. Okay, who has the instructions? There it is. Well, give me the address. Could somebody give me the address, please? 200. 200. Dot. 3. And 0/24. Right, and we want to go for 4 subs. 4 sub networks. All right, so first we need the mask. First thing, okay, with the instructions, get the IP address, we have it, get the mask and the number of subnets. That's the mask and that's the number of subnets. Determine the number of bits needed. So first, let's turn the mask into binary. So it's 1, 2, 3, 4, 5, 6, 7, 8 dot, that's 24. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then zeros. 8 zeros. Now we're gonna turn this into 4 subnets. Right, how many bits does it take to write the number 4? It's 4 is, this is the way it's written 4. And this is the way this technique is going. Says, okay, well then you need 3 bits. Then you go over 3 bits here. You go and leave those 3 bits. They'll be, normally this belongs to the network. This belongs to the host. And some here will belong to the subnet. So how many bits? And here we're going to take 3 bits, even though 2 will do. 2 bits can identify subnets 0, 0, 0, 1, 1, 0, and 1, 1. And there are 4 subnets. So I'm going to go with the 2 this time. 2 subnets. Usually, if you get, say, 4 happens to be a nice number, but if you get 5, then it have to be 1, 0, 1, and you're wasting, if 3 bits will give you 8 divisions, even though you only want 5. But with 4, we can go straight with 4. So I'm going to take the last 2 bits here and turn them into as part of the mask. So the new mask or subnet mask is going to be 88888 and 11. So it's a total of 26, not 24, followed by 6 zeros, and that's now the new mask. How big? Right, how many? Yeah, the division, how big each division is. You go in and find the first one here. What weight is it? 1, 2, 4, 8, 16, 32, 64. That means we're going to have 64, the increments. Every network will have 64 total addresses. So the first one is 200.5.3.0. And from now on, they're going to be /26, not /24. The next one is going to be 200.5.3.64. The next one is going to be 200.5.3.128. And you can keep going. We'll go for as far as 3. Right, for the first subnet, what's the last address for this subnet? This one starts 64. That means the one before it's 63. So this here is the last broadcast address. So it's 200.5.3.63 is the broadcast. For the broadcast for subnet 1 is 63. The legal address is 62. The first legal address is 1. So between 1 and 62 are normal addresses. 1 is the first legal address or host address, and 62 is the last host address. And in between, anything in between is fine. And the 0 is the identifier. Subnet 1 identifier. With subnetwork number 2, this one is the identifier. 63 is the first available one. 127 is the last available one. And 128 is the broadcast for subnet number 2. This is subnet 2, subnet 1. And you can go on the divisions.
27 is the broadcasted. 26.
Yeah, sorry, that should be the. Yeah, 127 is the broadcast. Sorry. Yeah, thank you. I done this on purpose just to see if you're following. So the broadcast is actually 127. 128 is the next network. Sorry, it's the next subnet number 3. Starts at 128. Then you add 64 to it. So these are equal divisions of subnets. You don't have to worry about this, but this gave you a good idea of what we mean by splitting a network into equal different parts of subnets. So let's get back to our it's always good to have those tables. So sorry, let me get back to see. The ones that tell you the mask. Okay, so this kind of table, you already have this. It tells you the different types. For example, the masks. The last mask here we worked out is this one here that has 2 1s and 6 zeros. Just for a second. There it is. There it is. /26 tells you this is /26. And that's the actual decimal number is 192. That's 128 plus 64. So if you're going to write it in decimal, it's 192. Okay, don't worry about that. That was just a nice introduction that brings us in. Now we're going to do the real work. So you have a couple of slides here for kind of questions, and you can try them out. Now, the CEDAR address is the short for the classless interdomain addresses. So this, forget about the classes A, B, and C. We don't quite forget about them, but we can divide even smaller than those classes. So here's an example. One address here, instead of /24, it can be any /20. And you can be asked, split this /20 address into smaller addresses. Remember, each time you add a bit, you're going to cut or split this into 2 halves, reduce the size, and have 2 networks, for example. But let's keep going. It's easier to do it this way. So first, there's a quick cheat sheet that you can have, that you can create, especially if you're doing an exam or if you go for Cisco. In Cisco, they give you an example like this and say, can you create subnet? And sometimes you get mixed up in those numbers. So it's good to have your own kind of cheat sheet, or at least be able to create one very quickly. So let's see. The general idea is pretty much the same. You're given whatever size network is, whatever number of addresses, and each time you split it in two, you are increasing one bit. So your mask is going to increase. So if you have a network /24, it will have 256 addresses from 0 to 255. If you split it into two, it's like adding one more bit to the mask. So every time you add one mask from /24 to /25, it's actually the size of the network smaller. The number of the networks double, split into two, and the sizes become smaller. So you can actually, looking at a network that has a mask 24, it's bigger than the one that has /25. It's twice as big. The total number is the same, but now you have more networks split into two, and everyone is smaller. And if you, the same network /24, you decide to split it again, twice, you split it once, and then each one you split it again, you're going to end up with 4 smaller networks. The point now is to keep in mind is that the smaller this number, the bigger the network. So /24 is bigger than /25. /25 is bigger than /26. Each network that's /25 is twice as big as an individual network of /26. So they keep getting smaller. We keep getting more networks, subnets, but they get smaller. And the higher you go, /26, you go to /25, it's a bigger network, twice as big. And you can work out, later on it comes in handy, this piece of information. So any network with any mask number, if you add that mask number by 1, that means you are going to get twice 2 more networks, but they're half the size. And if you keep doing it again, they're going to have more networks. So from /24 to /26, you're going to have 4 networks. From /24, you can split it into /27, 8 networks. How many? The difference between them, 27 minus 24 is 3, 2 to the power 3, gives you 8. So there's a quick way of working out how many subnets you can have, or how far do you need to go to get a certain number of subnets. But don't let it worry you too much. Now the attributes of every subnet, we've already done them. The identifier of the network, the first legal host, IP address, the last host, and the broadcast address. And don't forget, we need the subnet. So the subnet is also required for the mask, the subnet mask for that new network. This is just something to remember. If you have 1 with lots of zeros in front of it, in 1 byte, that has a value 128. This is just a quick conversion. If you have 2 1s, like we had in the last example, 2 1s, that's 192 in decimal, and so on. 3 1s is 224. So these numbers, people that work on subnets, they just learn those numbers. But eventually, they become so common to you. So if they're all 1s, it's 255, but we never have a mask that's full like that. Usually, at least 1 or 2 bits are missing. So in most networks, you won't get the last 2 here. There's no network with just 2 machines, maybe just 2 routers. But most subnets would be in this range here, where how many machines? This one here. If you only have that one, there are 128 machines. If you have those 2, it's 64. If you go, and stop at the first one, that'll tell you how many devices there are in that, the size of each network. So this table is a very good table. It gives you what the mask looks like in binary, what it looks like in decimal, but it also, how big is each subnet. But you don't have to worry about it. You'll be able to create this network very simply. And this is the way to do it. There's something to create a network. And I'd like you to be able to create this very quickly. We only need 3 rows, but we'll work it out. So first, all you have to do is write the number of bits, 1 to 8. Right? So the values, 1, 2, 4, 8, 16, 32, 64, and just keep doubling. And usually, when we start with the /24, remember, we have 3 bytes. The first byte, second byte, third byte, and now we're only talking about byte number 4, the last byte, just to make it easier. So up to here, you have 24 bits. This is where we start with our /25. So if you write here /25, 6, 7, 8, 9, up to 32. This is the last byte. How many bits are in the last byte? And these are the actual slash format of the actual mask. So that's so far we've written the numbers 1, 2, 4, 8 up to 1, 2, 8, and we've written the /25 to /32. And in between them, there's here, you're going to add that number to that number. So 128 starts, those 2 numbers becomes 192, those 2 numbers become 224, 240, 248, 250. Just add that to that number. This is the hardest part. Once you do that, you're finished, basically. That's the cheat table. It will be so easy to create any subnet out of this. All right. Those 2 here are left for the third byte and the second byte as well. But this is really what we need now for our subnet. But remember, if we go, just consider this now. This will tell you straight, if you want to convert /28, for example, or /27, it's 224. What's the other one? /31 is 254. /25 is 128. That's the decimal representation for writing the mask. Now, this is, if we bring the next byte, that's after the 16, and the next one. So for now, you can forget about those 2. All I need, and that's the first byte. After the first byte, 8 bits, and then becomes the 9th, and so on. But for now, we just want those 3 columns. I'll just go to those 3 columns. Yes, you see that cheat table there? So we started by writing 1, 2, 4, 8, 16 up at the top, and added that number to 64, added this number to the next one, and here we start /25 to 32. Now, you'll have to kind of, if you do go into Cisco and you want to do a Cisco exam, you'll need to be able to draw it very quickly, and it'll save you a lot of time. For now, I've got you the copy of this. Again, if I have more spare ones, I'll pass them on to you. Yeah. You can keep it if it's, hold on, if I have enough, you don't have to split it, just hold on. You don't have to split it anymore. Yeah. Anybody else is everybody got one full sheet of these? All right. Right. So first you need, well, we won't do it now, but you'll need to learn how to make that sheet. You make that sheet, you can subnet very easily. And this is how it's going to happen. First, let's get an example. And the idea here is that you can actually split any size network, variable size subnets. It's much easier. So let's go to this one here, attributes of a subnet. Let's say we have a subnet. We already have a subnet. What are the attributes of this IP address? 10.20.1.50/28. You go to the table and you look at /28. Anything. And these are the two figures that are there that are the two most important figures. They're just already calculated in your behalf. It says the slash of the network is 16. That's the size of each one. So if this one starts at 0, you can write now the first address of every network. 0, the next one is 16, 32, 48, 64, and you keep going. So where does this fall? The 10.20.1.50. It falls right in there between 48 and 64. This IP address, you can check it. Is it a good address? If it is. If it's 48, it's not good address. If 63, it's not good address. Because now, you know, this network starts at 64, this one starts, sorry, it's 48, and this one starts 64. The last address in this one, the broadcast for this one is 63. The first legal address of this one is 49. So anything between 49 and 63 is okay, and that's 50. That's a good address. So this gave us the actual division just by looking at that /28. It tells us how big each network is, how many total addresses, what are the increments, and it gives us also the 240 is the actual subnet of the address. So the mass address is 240. So it's all calculated in your behalf by just that sheet, the way you fill that sheet. It's easy to fill, and it's a magic sheet in subnetting, especially if you're doing an exam, because in Cisco, they don't wait for you for 10 minutes. You might have 1 minute or 2 minutes for each question. So if you have that sheet ready, you can almost work it immediately. So this guy here said, what are the attributes for this IP address? Where does it fall? What subnetwork? Which subnet? So it falls in this subnet, 148. And that's the first subnet, that acceptable address in that network. That's the first host address, and the last host address is 63, which is this one, and this is the one and then, was it? Yeah, 63, sorry, the broadcast of the last legal is 162, so this guy is 64, no, this is number 50, well, the next subnet is that, but this is the actual mask of that subnet. Is that clear enough?
Yeah.
Okay, good. So that right, this one here, how about this one? It's just reading the sheet there that we have. What are the attributes of this IP address? 10.21.37/29. How big is each subnet? How many addresses are there? You go to the cheat sheet at /29, 8. So every subnet will have 8 addresses, right? And then you can create them. You always start with 0. So that 10.20.1.0 is your always first one. And then you add 8. The next one starts at 8, 16, 24. This guy is 29. So it's between 24 and 32. So it falls in this subnet. 1, 2, 3, 4, subnet 4. And it's a normal address. If you find it has the ID address of a subnet or the broadcast of another of the subnet, then it's an illegal address. Sometimes that's what you're given in the exam. Then tell me this, for example, if you got this here 32 instead of 37, can you check this address for me? Okay, first 29, you see that's chunks of 8, increments of 8, start at 0, 8, 16, 24, 32. If this was 32, you say, oh, that's not a good host address. That's the subnet address ID. That's how quick and simple it is, but it's not all like this. So there are a few examples, you can look at them. Let's continue to this one. Let's make variable size subnets. Okay, you have the general idea again. Anytime you have lots of addresses, every time you go one more mask increase in the value of the mask, you're doubling the size, the number of subnets, but you're reducing the subnet size by half. So this is a bigger network, twice as big as 27. 27 is twice as big as 26. 24 is 4 times as big as 26. So now you can split or minus 26 minus 24, and you put that to the power of 2, and that gives you the number of nets or how big it is. So let's look again. /0, that's how they start. If it increases, it will become twice as small. You know, you have as two networks, and they're half as size as this one. And if you go to /2, it keeps splitting. So it doesn't matter where you start. That's the point. If you start at /18, /18 is always, you can have 2 subnets of /19, or 4 of /20, or 8 of whatever it is, the next 21 and 22 and so on. All right, so that's one idea that you need to keep in your mind. And you need to know the size of each one of those. All right, we always start with this one, say 256, right? It's the 1, 2, 4, 8, 16. Yeah, no, that's the total number of networks. So if you have one network here, it can go to 2, 4, 8, 16. The bigger the slash number, the mask number. Come on. And you can look at it this way as well. So /18 can give you 2 networks of /19, or can give you 4 or 8 and so on. You just keep repeating this. So the point is the number of subnets. For example, if you have a /10, how many subnets would you get out of /30, what is it, 11, 12, 13, 14, 15? And just say, subtract them all from /17. 17 minus 10 is 7, 2 to the point of 7, and gives you 128. So if you have a /10 and you want to get /17 networks, how many subnets would you get? It's 17 minus 10, and that's 7, 2 to the power of 7, give you 128 networks, which is logical enough. It's good you can do it if you only want to split it 2 or 3 or 4 times. You just keep doubling. But if this one is maybe /5 and I want /28, so it's too much to go from 5 to 28, doubling each time. It gets 28 minus 5, 23, 2 to the power of 23, and you can't calculate it. But let's keep it simple with smaller divisions. Now remember, the cheat sheet, /21. No, did we go 21? No, that's 21 below. Let's go now to, let's get an example. To solve netting variable length subnetting. Let's take an example. Here's an example. You get, and this is what you normally get either in a company or in an exam as well. You might be told, hey, we need to split our company into the following subnets. Like you get to a company, they have whatever it is. This could be accounts, this could be training department, human resources, whatever, different organizations with different sections of the same company. All they do, they tell you, hey, this is our IP address. It's /24. You automatically say, okay, /24, that means we have a total of 256 addresses. Now we're going to split them. You know how to split them equally, but let's now do it this way. And remember, you cannot give somebody 31. Each network that you're going to give is going to be either 4 or 8 or 16. So this one here is not going to get 25. The nearest is 32. We're going to have 32 here. This one is probably 64. The nearest power of 2. This one is the nearest is 16, and so on. So you're going to give, but that's okay, because in a lot of companies, they tell you we only need, say, 20 machines. But in a year from now, those 20 is going up to 30. So you can't give them 20, you have to give them 32, but it will be used, kind of thing. All right. And the other thing you need to decide, how many subnets do we have here? How many individual subnets? Now remember, every router, you go to a router that ends your subnet. So this here, that's one subnet. That's a router. That one and that one are not the same network from now on. They're going to be separate subnets. So we have 1, 2, 3, 4. This one is also separate. 5, 6, 7, 8. So now we're going to have 8 subnets. This is the smallest network in the world. It's always with router to router. It only has 2 machines. They used to only have 4 addresses left because the first and the last are not used. And recently they decided, okay, no, let's get rid of that for, if it's only 2 routers, okay, well, why waste 2 broadcast addresses? Because there's no broadcast. If this one sends, it will send to that. If that one sends, it will send to this one. There's not even a broadcast. A broadcast will have to send to multiple machines. So, but, okay, we'll see how it goes. Pardon?
First address, but then I could still reject the actual address that the software.
Yeah, the first part of the address cannot change. We can only change the last. Is that what you meant?
No, really. They just said they don't do a broadcast address anymore for route to route.
Oh, well, I mean, no, they might do, but if they do, the network only has these 2 machines. So when this one wants broadcast, it only sends to that one. It doesn't send to itself. And when that one wants to send, it only sends to that one. So there's no point of broadcasting because, you know, the broadcast when you have, for example, even those, for example, there are 3 here. You can send to this one or that one, but then when you broadcast, you have to broadcast to all of them. Here, you don't have an option. Either you send to the same one or broadcast. It's exactly the same. You're not gaining anything. But anyway, leave that. That's a side point. Let's start with this. First, you start with the larger one, guys. You start first with the whole lot, /24. That's what we're starting with. And we need to pick the largest one, and that's that one there, 50. So we can't give it 50, okay? But we can give it, this is the normal kind of grid that you have. This is 256, that's 128, that's 64. It looks like this 50, it'll fit in the 64 one. So first thing, we're gonna give that part here, /26. So see, immediately this changed from /24 for this one, it's /26. So you pick that one, you decide, okay, we're gonna allocate this one to /26. So this network that has 64 addresses will allocate this particular network. What address will it be? That's you book it, you mark it. Now those addresses are gone from 0, 1, 2, 3, 4 up until 63. Right, so those first few addresses are allocated to the second network. Now, /26, looking at it here, it has 64 addresses, but that's more important to me, is the actual slash number, the mask is, what do you call it? It's /26, but if we write it in actual decimal, it's going to be 192. Now, what's the next network, the next biggest network? This one here, 31. 31 is a little bit awkward. They want 31 machines. Remember, then you put it in a network, you need to have 2 extra addresses. So that's a total of 33. Make sure you always include 2 more. unless you are very clearly told, oh, that includes the broadcast and the ID. But 31, that means you need 33. 33, where would you fit it? This one is 64. If you divide it again, 32. That 32 is not enough to locate that one there. So we have to go for the next one. So the next one is another one of these. And therefore we go for the same size, which is 64/26. So we select /26, and we give it the next division here. So all the numbers from 64 to 127. That's allocated to the second subnet. So we use now half of the available kind of capacity. The next one is that 25. What's actual size and what's the /what that give us that we should allocate to the top network there? Any idea in the corner there? This network here, 25. You look up there and see where it will fit. Obviously, that's the number of the size. So 16, that's 25, that's 32. So 32 is the first one available that's fitted. And 32 is /27. You understand that? Do you get that up there? So this network is going to be smaller network. Where is it gone? /26, /27, sorry. This one here. Why /27? Because it's only, we're getting the 32. So /27, we can give it one of these, but this is already, these addresses are already given. So the next available one is this one here. So this is the path that we're going to allocate to that network. And you also need to find out, where does it start at? What's the first address? It's 128. What's the first address here? The ID address. Where is it? Which one is this? This one here, right? The biggest one. So it's 0. That's 0. This one here starts at 64. Right? Now the next one starts at 128. And because this is a 32, where does it end? It ends at this address here, which is 160, I think, 159. So this one falls right in there, a size 32. /27. What address will it have? 83.4.2. What's the address of this one? 128. That's the starting address. That's not the starting, that's the ID address of that network. Are you following me, guys, there? Okay, what's the next one? Where do I go? Which network here will I pick next? So we've already done those 3. What would be your next network to pick? We go by the largest first. See, this one they told us they need 50. This one 51. This 25. What's the next requirement? How many addresses? This one they need 10 machines, 19 and 12. So that would be the next biggest one. So we're going to pick this network. Now, we can't give them 19 devices. What would you give them off the table? See, the top line will show you. The top line will show you which one would you pick. For the 19 here, where would you go? You give them. You're not with me, or? 32. Yeah. So 19 will not fit because this network can only take 2 machines, but 4 machines, 8 machines, 16, 32. The 19 will fit into a 32. And the next available 32 is /27. So that's the 27, the next one. So we can allocate this part here. This has 32 addresses. What's the first address for this one? The ID for this section? It starts at this address here. So that one starts at 0 to 64, 64 to 128. 128 is the next one. And this one plus 32, it's 160. So this one's going to start at 160. And that can be clearly indicated now in the address. So there is 83.4.2.60. And that should be that for that one. And instead of 19 machines, we'll give it 32 machines. Right. What's the next one? This network, 10. Oh, sorry. Go on. Right. Yeah, exactly, because it's 12 will fit, the first one will fit 16, that's slash 28. And what's the first address? 192, and it's in the slash 28, that means that's the size 16. These are the size of each of those networks. So that's slash 28, size 16, and the first address is 192. Okay, so it's real nice and neat, and you stack them according to what you need. Right, the next one, number 10. Who's going to do number 10? One of you guys at the you. Okay, you. The last one here. We need 10 machines in this subnet. What slash number would you give it? What mask? Look at the top line. Where would you fit 10? 1, 2, 4, 8, 16. Well, they'll fit in the 16, right? And the 16 is a slash 28. So slash 28 is this one again. So I guess we give it the next chunk that's there. And the address is 192 plus 16. I can't remember what number that is. 202 and 6 is 208. It starts at 208, right? And there it is, slash 28, 208. Perfect. Right, who's going to do the hard one now? The next one. The next one here needs 2 addresses. Where will it fit? Up in which slash mask? No. Okay, it's right here. In the older days, they used to say, give it 4 addresses. I don't know what way now is used here. In the newer implementations, say, no. There's only 2. So you can either pick the 254 or you can pick the 252. I don't know which one they picked here in this example. So it's either slash 31 or slash 30. Let's go for the slash 30. Remember, you always add 2 to these addresses. 19, work for 21, work for 14, work for 33. This one, especially this one. Very close to 32, that's very dangerous. Remember, every network is either 8, 16, so the numbers 8 and 16, 32 are very sensitive. So I guess even for those 2 routers, give it 4 addresses. So go for the slash 30. Okay, you with me? All right, slash 30, that means that slash 28 that we have there would be slash 29. So they split each 16 into 8, and the next one split each 8 into 4. So we go for 28, 29, 30, and let's go for that then for the 30. Why is it not working? Yeah, so we go for the slash 30, right? Okay, they're just, we can't see them now, but imagine we have the division there. Probably in the sheet I gave you has that stronger division, smaller divisions. No, that doesn't. So if they're not there, you'll have to split them yourself like this one. You see, in there, this part here can be split into 2, and then each one is split into 2, and that's at the 30. And each one of them can have 4 addresses. The first, the broadcast, and the 2 addresses that one will be given to this router, one will be given to that router. Are you okay with this? So what's the network identifier for this subnet? What's the address for that subnet? Remember, we're going to have this one right here. We're going to give this network to that one there, this part here. That starts, hold on, yeah. After those 2, we finished with those, so that's the next available one. I don't know what this address, 192 plus 32 is 224. I think it's 224. Yeah. So that's the one we're going to allocate to this network, and it starts at 208. Why 208? So 192 plus 16 and 16 is 32. So it starts here. That's 208, this number here. And it only has 4 numbers, so it goes 208, 209, 30, 31. So the next one should start at 32, this part here. Yeah, and they've decided to go for /30. So they allocate them at 4 addresses. So this one is this is 224, identify this part. Now this will probably, one of them is going to be 225 and 226. And then 227 is the broadcast, then 228 is here, starting here, identifier. This would be 229, this port, and that would be 229. And that ends this example. So I don't know if it looks, this is as easy as it's going to get, provided you have that cheat sheet. You're going to just kind of line them up, put them in the right size based on, it's like fitting different sizes into different pigeonholes that will take them. You only will know it when you have an example and you try it. So you have this sheet, the same sheet as this one, and you have the actual cheat sheet at the top. We'll try and do the next example. Okay, this one just, I think this one belongs to 10530. Yeah. All right, then you need to give each individual network here, what's its ID? The blue one, this one here, 83.4.2.0, that's its ID. What's the first legal address? What's the last legal address, and what's its broadcast address? The broadcast is, this one starts 64, that means this one's 63. So, and that's what's in the next sheet here. That gives you the exact parameters of each subnet. The identifier, the first legal, the last legal. So any number between 1 and 30 is okay to give to a host. 31 is a broadcast, cannot be given to a host. And then the next network starts at 2. The next network is same size, /27. When we say /27, it's a mask, but it's actually a good indication of the size as well. So they're the exactly same size. When we go to /26, that's a different size. /25 is even different sizes of network. That should not be, yeah. Hold on. Yeah. The first address should be 26. This one should be 26. This one. Okay. All right, I'm gonna give you another IP address, and I want you to work out either one of those. Not the one we've already, no, that's 5 and that's 4. It just finishes this one. 2 addresses cannot be received. No, I'd like to give you an example to do. Give me one moment, let me find the example if it's there. Sorry. Okay, I'll just write you a quick example here, and I'd like you to do. It's nearly time, but okay. So it's this address 200.10.10.0. I want to /24. Yeah. All right. Let's it's a router. That's a router. Yes. Okay, we have 5 networks. Well, no, I'm not telling you how many networks, but that's a router and that's a router. And these are the links. So this is subnet number 1. We want it to be 140. Let me get this for you. Right, there you are. This is the requirement. We have, you arrived into a company, they said, hey, we're going to have this network. We're going to split our network. We have 2 routers. We're going to split our networks into 4 main subnets. 5 computers here, that's 16 there, 40 and 100. Hold on, that's yeah, give or take. All right, please start off. Give us the actual subnetting for this variable length subnets. You already have everything you need. You have the /24 is your mask. Create every subnet with its mask, its ID and its mask. Use the cheat sheet, which is, there it is. We'll put the light on here. No? Maybe I'll put more. I go over it with darker colors. Yeah, that's better. This is a router, that's a router. Remember the shape of a router, or the symbol of a router, usually it's roundy. The switch is always, when you see a switch as part of the same network, but a router brings you outside the subnets. All right, how many networks do we have there? Good answer, but it's the wrong answer. Yeah. All right, don't forget the extra network we need. Do you know where those 5 networks are? No? Every side of a router is a network. Right, so this side of the router, 1 network. That's 2, 3, 4, and this is a separate network. So 5 networks, and you need to decide how many go there. The guys in the company, they don't know about, routers, how many, but give it 4 total addresses. There are only 2 machines, so you have to ask, are you finished? Are you finished? No? You need? No? Okay, you want to start? Have you started? You want to know how to start? You're not doing this? Guys, this is fairly, if you don't learn it today, you'll learn it, but it'll take a bit longer to learn. So try and do it now and ask me. If you have an issue, how to start, put your hand up. I'll tell you how to start. You okay, guys? Yeah, ask away. You'll manage it, no problem. Okay. Maybe I should have a prize for the first person to finish. I don't have any prizes though. A pen, how about a pen? Looking for a good pen. There isn't even a good pen in my collection. You don't know how to start, please put your hand up. You're going to start with the biggest, largest network, subnet, and give it number 0. That's the address 0. And the address 20, 10, 10, this is the address of the company that company has. Got 0/24. /24. How many machines, how many addresses are in the /24? There are 256 addresses. The cheat sheet will tell you, where's your cheat sheet? Like the table up there at the top. You finished? All right. Now, in the exam, don't give me that. That won't get you lots of marks. I need, like, for each network, there are 5 pieces of information. Its parameters. Where does it start? What's its ID? What's the first address? What's the last address? What's its broadcast? And what's its map? Okay, so 5 pieces of information. I need 5 pieces of information for each network. And if you do it in the table, it's nice to mark where do you put that network. Where do you put that? Make it easier for me to follow your answer. You say, I'll put the first one here, or there, or there, or there. Give them numbers maybe as well. Shall I number them, or P1, or subnet 1? Now I'll mix things up, leave it. Anybody wants to know how to start? You want to know? Yeah? Okay. Let me get the cheat sheet if you don't have it. You have the cheat sheet? All right, that's all you need. You don't need it. Right, so first thing, we start with, this is what we have. We have 226 addresses. That's 24. Now we're going to give the biggest one. We pick the biggest one. The biggest subnet. They want 100. So where you look up here and see where we fit 20 machines. This one, a subnet with 2 machines, 4 machines, 8, 16, 52, 64, 128. That's the one. So we go to the 128 machine, so this one, we give it this half. So the first network will take half of all the, so it's a 25. So, right, so just do something. So let's say this is the 100 machine. So what happens, it gets, the first one gets the actual address, the original address, but we should have it with a different map. So the first network will get the first address, but the slash is going to be the new slash number, because the smaller one is going to be a bigger slash number, bigger mask. So that's your subnet 1. You say my subnet 1 is going to have, yeah, its ID is 200.10.10.0/25. Okay, and you have to, so what's the first? So that's its ID. What's the first legal address you can give to a computer? Where is the last address of this? If you look at this starts at 0 here. Goes up all the way to 128. 128 is the second, the new one, and the next one. So 127 is the last address. Let's go to those last addresses. So you rise the line. In between, the one before this is the last one. So that's the first legal address. So all of this idea is something. Subnet 2. What's the second network you're going to put here? 40, 16, or 5? It's the 40. So where would you fit it up here? Yeah, so it's going to be 26. The last one was slash 5. So it's going to, its ID is going to be this number here. But where is it fit? It's here, right? Yeah. So this is like all of these places. So now, using those numbers, maybe I can do the wrong ones. All right, anybody want to show me where did they put the first subnet and the second subnet? I'm just marking. Yeah. Right. Yeah. Okay. Would be right.
I mean, yeah. Right.
Okay. So anyway, the next two addresses are the four addresses going I don't have the numbers now, but what's the first? What's the ID for the first one? All right, and what's the broadcast for the first one? The first legal address and the last legal address? Now, in an example, in a format, we always read on that's also would be nice to have. Okay, this is where subnet 1, 2, 4. You don't have to do it. It looks good. Sometimes it looks good, but if the numbers are slashed on the way and slashed on the right, be careful. Okay, I think. What's the broadcast for the first sentence? Yeah. How are you doing? Okay, you can go home if you want. That's not the one we're talking about. These are the actual requirements. No, this is the requirement of the company. The company is the 60 departments, the finance, the training, engineering. That's what they want. So you have to divide your network not into smaller subnets for combinations of different size. But you can't give them examples of 50, 64. Two, 4, 8, 16. What's the broadcast? We get this one they need 31 machines, but you must have 2 more addresses. So 53, 8, 16, 32, 64. Because every network here, if they tell you we need 5 machines, don't forget you give them 2 more. You have to give them 7 addresses. You need 7 addresses because there's an address So for identification and address for broadcast, still 8 uncovered. This one, if they tell you we need 16, I have to get them now. Hold on, I have to get them 18. So 2, 4, 8, 16, 32. You have to get them 32, which is just on the edge. This one here, you give them 40, you have to give them 42. Okay, 64 will do. And this one is 100, you can't give them 100. The next one, 2, that's 120. So this one will actually get 128 addresses, 64 addresses, 32 addresses, and 8 addresses. And here, 4 addresses. One for this one plus 2. We'll always add 2. Okay, guys, I hope you can do it. Practice it. It's a definite exam question. Subnetting. There's always a question on subnetting. But some training or some try it a few times, and you should master it. Thank you.